Welcome to the tutorial for the free download SDK of Elektrobit's corbos Linux for safety applications. Why Elektrobit corbos Linux for safety applications? What we're doing is bridging the gap between open source software and the classic automotive industry. The reality in automotive, as you can see on the left, is that there are long product life cycles. You have restricted high cost storage and memory, and you have targeted code changes. You only want to get code in there that fixes what's broken. But in the open source world, you have very short product life cycles. Things move very fast in the open source world. You have rapid innovation and hardware that supports a lot of processing power and a lot of memory. And generally, if you want to get fixes and patches, you need to upgrade your whole system, which is something you don't want to do in the automotive world because that's going to lead to a lot of testing and recertification effort. What does the automotive industry need? Well, automotive industry likes non-proprietary software, so something open source. The automotive industry does not like getting locked in to software from single suppliers that cost a lot of money and again, make them beholden to a single supplier. Of course, the automotive industry needs software that is qualified generally to automotive spice. Of course, it has to be reliable, because that's what customers expect when they pay a lot of money for a car, and they need a solution that is well maintained, especially now that cars have become connected. There is a lot of hackery going on in the automotive industry where the bad guys are trying to hack our vehicles, and so you need to keep the software in the vehicle maintained to ensure that it always meets high safety and security standards over the lifetime of the vehicle. Why do we want to use Linux in the first place? It has a lot of features. It is super feature rich, as anyone knows who's ever used Linux. It's robust for common use cases, right? It's a general purpose operating system, so it can do a lot of things. You have a huge developer pool. So Linux, in comparison to other proprietary solutions in the industry, uses an open collaboration model where you have a lot of developers even doing it for fun, or many developers also developing Linux professionally, so in the pay of companies. So instead of just having a pool of developers in one company, you have developers all over the world working for many companies or developing Linux for fun. Of course, there's a well-known API since Linux is so broad and so widespread and deployed all over the place in servers, desktop, and embedded devices. People know the APIs. For example, POSIX is a well-known API that Linux, of course, supports. There's no vendor locked in, as I talked about before. Of course, Linux evolves rapidly because there's so many people working on it, and the industries outside of automotive that use Linux are demanding that rapid evolution. And of course, you have broad hardware support. Linux will run on many embedded targets as well as non-embedded hardware. And of course, it's easy to debug because it's open source. So you have source code transparency and also a bunch of open source tools you can use to debug a Linux operating system. Of course, there are compliance challenges with an operating system in automotive in general, and with Linux, since Linux is not coming from the automotive industry. You have complexity and integration of components. So you really need to get all of those applications coming from best-in-class providers for ADAS, et cetera, and get them all onto that operating system. Of course, you have to adapt from older standards in the industry continually. You have the functional safety certification process, which is fairly new, fairly arduous, and fairly complicated. And of course, you have diverse development approaches, build chains. So you've got to bring all of these things under one umbrella. You also have a maintenance challenge. So if you look on the left side, you can see that there are thousands of kernel security updates over an 8-year lifespan, which is generally shorter than the lifespan of a vehicle, if you think about it. And of course, you will have 44 kernel releases in that time. Now, the way to generally do that in the Linux community, for example, on servers or desktop deployments, would be if you wanted to get the latest security patches and updates, you would have to upgrade your whole Linux distribution. But that's not something you want to do in an automotive embedded setting because that would mean recertification, it would mean retesting. You really only want to get those fixes, those few patches in that you actually need and keep the rest the same. So you have a maintenance challenge. What is the big deal with maintenance anyway? Why do you need it? Well, why you really need it is security. There are Linux being open source. Everyone is looking at it. Zillions of people out there are examining the code, working with the code day in, day out. And so security issues are exposed in Linux, which is a good thing, because if you find those security issues, then you can fix them before the bad guys find them and exploit them. But then, of course, you've got to get the fixes for those issues deployed to your vehicle quickly. So what do you get with Elektrobit's Corbos Linux for safety application? You really get peace of mind. The regulatory environment, the compliance environment is a minefield, as I talked about before. The maintenance is super security because of cybersecurity. And as you can see from this slide, there is a bunch of standards out there that you have to fulfill. And so Elektrobit takes the burden of fulfilling all those standards, playing by the rules in the automotive industry, not getting into trouble, not having people come and hack your car. By using EB Corbos Linux for safety applications, you are sure that you're going to be in compliance with all of these regulations. You're sure that you'll be able to navigate this minefield without getting into trouble. Looking at EB Corbos Linux for safety applications, what really makes it special is the 4 safety applications at the end. So it is a Linux based on Ubuntu, but it complies with ASIL-B SIL 2 safety requirements, which is something totally new for a Linux distribution. The industry for many years has been trying to build a Linux that complies with automotive functional safety requirements and has failed. And Elektrobit has finally managed to do that. And I'll talk a little bit more about how we managed to do that. So again, with EB Corbos Linux for safety applications, we are bridging the gap between the open source world and the automotive world. The goal was to have a qualified, reliable, and well-maintained Linux distribution. And we have accomplished that with the help of the TÜV Nord, the certifying body for this, of building a Linux which you can use for safety applications that allows fast project startup, fast development, and of course, fast innovation cycles. So EB Corbos Linux for safety applications is the first and only hypervisor-based safety extension, Linux OS, that complies with ASIL-B and SIL 2 safety requirements. We provide up to 15 years of maintenance for cybersecurity. We allow you to get to market 50 times faster by using a Linux and the tooling that we provide around Linux and the packet that we put together that allows you to quickly get a Linux which is safe and secure into the car. Of course, during the lifetime of the vehicle and during production, we provide immediate defect notifications as soon as they come out from the community and get those fixes to you as quickly as possible. We eliminate the entry barriers during development by providing tools that allow you to configure your Linux, to build your Linux so that it really fits the needs of the vehicle or of your application with no more and no less. And of course, there's high trust. By having an open collaboration model, an open development model, you can see the code, you know who's developing things. That gives you trust instead of relying on some company's operating system where the company is doing whatever, it's not transparent, you don't know. By using open source and working with Elektrobit, you know what's happening, and that allows you to build trust. Okay, I said I was going to tell you how EB Corbos Linux for safety applications work. This is what it looks like at a high level. So at the bottom, you see a system on chip, that's the hardware, which of course you need. Then you have a bootloader, then you have a hypervisor, and that's where the magic happens. You can see this OS safety monitor on the right. That allows you to run safe applications on top of Linux. Now, on top of the hypervisor, you see 2 partitions. One on the left, that is a quality managed partition. So that would be a Linux that is compliant with the automotive SPICE. And on the right, you have a Linux that is compliant with ASIL-B based on EB Corbos Linux for safety applications. The way it works is that we don't actually try to make the Linux kernel safe because it's too big and too complicated and changes too often. So even if you could make this big thing safe today, you would need to change it for cybersecurity, and then you would make it unsafe and you'd have to recertify it. There's no way you can do that. So instead of trying to make the big complicated Linux kernel safe, what we did was we put Linux on top of the hypervisor. We put the OS safety monitor in the hypervisor, and that OS safety monitor runs at a higher privilege level than Linux and ensures that the unsafe Linux kernel cannot interfere with the safe applications above. That's why it's called Linux for safety applications, because it is not a safe Linux, because you don't need a safe Linux. You don't care if Linux is safe. What you care about is your application being safe, and we allow you to run your application on top of Linux and have safety without actually having to make the huge, complicated, and very dynamic Linux kernel safe. What would be some real-world applications that you could use Linux for safety applications with? I mean, generally you need an application with ASIL B requirements, so not the highest level of safety requirements like ASIL D. So you wouldn't want to run a braking application on top of this or a traction control application on top of Linux, because you wouldn't get the real-time requirements. Linux and the compute hardware on which Linux runs is meant for high compute throughput, but not exactly high determinism. So you need something ASIL B, generally involves user interaction. So the software is interacting with the driver, generally not hard real-time requirements, but you do have high compute requirements. So that's where you get into the realm of advanced driver assistance systems. So for example, warning the driver if the telltales in the instrument cluster are not working properly. So for example, if there's an engine fault, then the instrument cluster needs to signal that, and if that function isn't working, then the driver needs to know about it. Or for example, real-time pedestrian detection, right? You may have a night vision system that tells you, oh, there's a pedestrian about to cross the street, and warn you of that. And if that system is not working, the driver may rely on it. You need to at least let the driver know, hey, this pedestrian detection system isn't working. You need to really pay attention now yourself. So those are typical use cases for which our Linux for safety applications is well suited.